Hi everyone, welcome back to our EV channel. Today, let's try to discuss about what are different electric vehicle or internal combustion engine vehicle performance indices or vehicle performance indicators. So this plays very important role in identifying the performance of an electric vehicle. So coming to the concept, so this very important question in academic point of view. So the first one is we want to establish the performance indices. First performance indices is maximum cruising speed. Okay, so maximum speed of the vehicle or maximum speed of the vehicle is called maximum cruising speed. Cruising means it's nothing but a special control accelerator, special accelerating speed or maximum accelerating speed. And second evaluation parameter is gradability. So is nothing but gradability. So this is nothing but how much grade angle an electric vehicle can climb, which is nothing but the grade or the grade angle. So here the EV has to travel in this grade angle, that is called gradability. Based on this gradability, we can say whether that electric vehicle is good or bad. It's called performance indices. Third performance evaluation is the acceleration. Acceleration is indirectly is nothing but at how much speed it can travel we are going to calculate. So these three are called as a vehicle performance indices for an electric vehicle, and it's very important. So this performance indices remains same for an electric vehicle. This remains same for an internal combustion engine. Let's try to discuss each performance indices individually. First one, let's try to understand what is meant by maximum cruising speed. Okay, what is meant by cruising means is nothing but speed controller, maximum accelerating speed, maximum accelerating speed. How to decide the accelerating speed of an vehicle? So here we are going to have some empirical formulas. So these are directly empirical means based upon the phenomena happened. So the equations are framed. Okay, let's try to discuss the maximum cruising speed. Okay, so how to get the maximum cruising speed is when you equalize the tractive effort. Okay, when you equalize this tractive effort to all the resistance parameters. Okay, let's try to understand the tractive force or the tractive effort. So ft is called as a tractive effort. This is called tractive effort or tractive force. What is tractive effort or tractive force means? This is the force to be developed by the vehicle to move from initial position to final position, or this is the force required by the vehicle to move forward direction is called as a tractive effort or tractive force. This tractive force is nothing but the force developed at the vehicle, which is also called as a, so already we have been derived this derivation. So tractive force is tractive torque divided by the radius. So what is the torque developed at the wheels? It is nothing but this is an ig I naught into efficiency of the plant and torque of the engine divided by the resistance. So this is by considering all these five parameters, the vehicle will start propelling on an road or vehicle will start moving on a road. So this is the force required by the electric vehicle to propel on an road. So this force is which is trying to move the vehicle in forward direction. So these forces are also, this force is opposed by an opposite force. So electric vehicle is trying to move on the road, but there are some forces which are acting in opposite direction to the vehicle, which is making the vehicle not to move forward. Let's try to discuss those forces one by one. So first force, so here tractive force, let me substitute tractive force is equal to first product is nothing but m mass mg into fr cos alpha. Okay, so this is nothing but you can define this as one factor here in this parameter, where we are going to call as a mg is nothing but total mass of the vehicle. Mg is nothing but mass of the vehicle. It may be an ic vehicle or it may be an petrol vehicle. So fr is called as a rolling resistance. So fr is nothing but the rolling resistance offered by the electric vehicle or IC engine, where cos alpha is nothing but the gradable angle. So how to calculate cos alpha is, so when you take an vehicle is on an road, so this is the road we have generally for consider we are traveling from Tirupati to Tirumala. Okay, when the vehicle is trying to travel, so our electric vehicle is like this and is trying to travel on an road. So when you have an electric vehicle, engine weight is here and it is going to have an vertical component which is nothing but mass of the vehicle multiplied with sine alpha, and you're going to have the vertical component which is due to gravity, so the mass of the vehicle multiplied with cos alpha. So this I am taking it as vertical component, this I am taking as an horizontal component. So the vector addition of this is going to produce these two forces, so where this is called as a mg. So now I want to find out what is the angle or the gradable angle. So this is nothing but I'm going to find out alpha here. So how to find out cos alpha? So cos alpha is nothing but the gradable angle. So cos alpha is equal to, this is the opposite side and what is adjacent? So this is nothing but x I am taking. So this is nothing but adjacent side divided by hypotenuse. What is the hypotenuse? Mg. So what is the x is nothing but already we have defined this x, we can write down it as so this x. Okay, so cos alpha, this x is nothing but so cos alpha means adjacent side. Okay, so adjacent means 90 degrees to this, which is nothing but mg, just a small correction. So mg cos alpha, mg will get cancelled, we are going to get cos alpha. So similarly you can find out sin alpha. Sin alpha is x divided by mg. So if you want to find out sine of that angle made by the vehicle, where it is called alpha, cos alpha is nothing but opposite is x by mg. We have to calculate x, which is nothing but mg into cos alpha. This x is nothing but mg into sin alpha. This vertical is nothing but we are going to find out cos alpha. Cos alpha is, so what is the 90 degrees? Mg cos alpha divided by mg, we are going to find out cos alpha. So what is the total force which is acting like an rolling resistance? Okay, so this is called as a the rolling resistance mg cos alpha. Mg cos alpha is called as a tire rolling resistance. It's called as a tire rolling resistance. Now let's try to find out. So this is called as rolling resistance coefficient, and this coefficient value is generally, if you turn on an concrete road, this is 0.01. So the rolling resistance, if it is depending upon the type of road, it will change. So the rolling resistance coefficient Fr is 0.01, is a one force which is acting in opposite direction to that of the original torque, plus one more force. Okay, so I'm writing the forces. We have been defined first parameter. Let's try to define the next parameter, which is nothing but so that force is nothing but so this is an sum of these two. So this value is given by half into rho a into CD multiplied with AF V square. So now we want to define what are these independent parameter. So what is meant by rho a means where rho a is called as air density. So A is air, rho is called density, and what is CD? So what are the suppression force? So there may be an air density and there may be an aerodynamic drag coefficient. So AD is nothing but aerodynamic drag coefficient. So drag C is nothing but just an indication. We can change whatever we want, but we have to follow some standard books. So it is a product of half rho A CD AF. So what is meant by AF is called as the vehicle will have some front area. So this is called vehicle front area. So the electric vehicle is having or an IC engine is having front area where V is nothing but the vehicle speed. You see here, the air density is offering an opposition. Aerodynamic drag coefficient is also offering an opposition. Vehicle front area is also offering an opposition, and this all multiplied will try to move the vehicle in an opposite direction. So now let's try to equalize all the forces. The original tractive effort which is produced is given by what is the original tractive force? So we have Ft. So original tractive force, the original tractive force is equal to, so let's try to simplify all the parameters one by one. So when you simplify it, so what are the forces left for us? So Ft is equal to, first one is what is the formula of Ft? This nothing but Ig I naught eta t into Tp divided by Rd is equal to, what is the first force, which is nothing but mg Fr cos alpha. Okay, so two forces are acting on the vehicle. Okay, so what are those forces? Which is nothing but first force acting, which is nothing but mg Fr cos alpha is the force which is acting. So these forces are nothing but tractive force trying the vehicle to move forward direction. So these are the forces acting on the vehicle to move in opposite direction or the position. This is the mass of the vehicle. This is called as rolling resistance coefficient. This is nothing but the gradable angle plus half into rho A, which is called air density factor, where CD is called as aerodynamic drag coefficient, and AF is called as vehicle front area multiplied with the velocity. So when you do all this and equalize, so this is called as tractive force, and these forces are trying to move the vehicle in forward direction, and all these forces are trying to make the vehicle to move in opposite direction. That's how we have this tractive force. Now let's try to draw a graph to understand all these parameters. Okay, so how to draw the graph is nothing but so you can have these two forces which are acting in opposite direction. So the rolling resistance. Okay, here we are saying about the rolling resistance. So Fr rolling resistance, which is called as a rolling resistance coefficient. So this depends upon many factor. Okay. So rolling resistance coefficient for cement, I mean for concrete, we are taken as 0.1, and this is rolling resistance is directly proportional to some factors. So rolling resistance is influenced by some factors like the type of tire material you use for your vehicle. It depends upon the first one is tire material, second one is an depends upon the tire structure. So you can have each individual brand like MRF and you have these JK tires. They provide different tire structures and they use different tire materials. So the rolling resistance coefficient will change depending upon the type of tire material, tire structure, and next one the withstand capability of the, I mean temperature withstand capability of the tire, and tire inflation. So tire inflation. So what is meant by tire inflation means if the temperature increases, the size of the tire is also going to increase. This is also affecting the rolling resistance, and This is also inflated by tire inflation and tire inflation pressure. And next one, the tire has internally some threads. This depends upon tire or thread geometry which is there inside the tire. And road, so road resistance basically depends upon the road roughness, and is also proportional to road material. Okay, what kind of material is used, tar road or concrete road. So all these factors are going to affect the rolling resistance. Okay, so that's how we, based upon this formula, we want to find out what is the maximum velocity developed by the IC engine. So we need to calculate the maximum velocity developed by the IC engine. Let's try to plot the curves one by one. So let's try to see here, IC engine or our electric vehicle, both will have the same. Let's try to draw those characteristics here. So I'm going to draw the characteristics. I'm considering x-axis, on the x-axis I'm going to have the speed traveled by the vehicle. Speed is nothing but in terms of kilometers per hour I'm considering. On the y-axis I'm going to take tractive effort, which is nothing but ft, and I'm going to consider the rolling resistance offered by the vehicle. So when I plot it, then you can see how this v maximum is developed. So whatever you got the graphs here, so we have been got an empirical relation. This empirical relation we are going to substitute onto an formula to understand these graphs. Let's try to see here. Already we know this tractive effort curve is like this, and you may have different. So this is nothing but low speed, 100 rpm, 200 rpm, 300, 400, and take this is some maximum speed of the vehicle, and take this is the nominal speed of the vehicle, and this is nothing but center or critical speed of the vehicle. You can see here. So already this curve is discussed. So when you have lower speeds, when you have lower speed, the torque developed by the vehicle is higher. So that's why it is having more tractive. So every electric vehicle at lower speeds can have high tractive effect. So that's why we have the curve here and slowly it decreases. And you can consider this as an first gear also. So this is how we have the interaction, and the resistance we are going to draw it for different degrees. Okay, so we take the rolling resistance with an alpha of cos alpha. We are going to have it for 30 degrees, and here we are going to have the curve for 25 degrees, and here we are going to have for 20 degrees, and here we are going to get it for 15 degrees, and here we are going to get it for some 10 degrees, and here we are going to get it for 5 degrees. So these are the different types of cos alpha values. We are going to get different types of rolling resistance. So when you interact, so this is nothing but, the force dollar. Okay, so this is nothing but the tractive force, is the tractive force developed by the vehicle, and these are the opposing force which are developed by the vehicle with different types of grade angles at different grade angles. So the intersection of these points of tractive force with the opposing force, we are going to get some intersecting points. So when you try to plot it on a computer, then we can calculate what is the maximum velocity that can be developed, where this is called as a maximum tractive, which is called maximum cruising speed. So this is called as a, when you plot the interaction, we are going to get maximum speed, or we are also called maximum accelerating speed of the electric vehicle. So this is called the maximum cruising speed. We are going to get this maximum cruising speed by the intersection of tractive effort with the resistance versus an speed. Okay, so if you take, and this I am taken as these characteristics are general, this is the characteristics of an IC engine. The same characteristics will also be exhibited by an electric vehicle at different speeds. So that's how we are having this intersection curve. So this intersection curve will give you the maximum value, or which is called the maximum cruising speed of an electric vehicle. Hope you understood the first one, which is nothing but the performance indices maximum cruising speed. That's how we are going to get the maximum cruising speed. If you want to recall, you can just recall. So here you have two forces acting on an vehicle. So the first force, which is nothing but Ft. Okay, so let us try to see here in detail. This is nothing but the tractive force, which is nothing but tractive force is Ig, I naught, eta t, I mean the torque of the plant divided by Rd, where this is called as tractive force, and the forces which are acting in opposite direction are nothing but the mass of the vehicle, which is called as a mass. Okay, every vehicle has an mass. And next one, rolling resistance coefficient, which is nothing but Fr. Okay, so this is nothing but on a concrete road you are going to get 0.01, and this is nothing but the grade angle experienced by the vehicle. This is nothing but cos alpha. And the one more opposing force which is acting in opposite direction is half rho a cd. This is called air density factor. B is called as the aerodynamic drag coefficient, where AF is called as vehicle front area and V square is called velocity. When you plot this equation on an graph, we are going to get same characteristics. So the same curve also we are going to get if you are going to draw for an electric vehicle. Same curve we are going to get. If you want to consider for an IC engine, you take it for first gear. So this is for second gear, this is for third gear, and this is for fourth gear. You can see here at first gear low speed, at second gear moderate speed, third gear also little bit moderate, at fourth gear you have maximum speed but the torque developed is minimum. So that's how we are going to have multiple parameters of the system. This is all about the maximum cruising speed developed by an IC engine or developed by an internal combustion engine. These are the original characteristics of an IC engine, which is also similar. So, what is the conclusion we are giving it? We can replace an IC engine, we can replace an internal combustion engine with an electric vehicle, or you can say that the performance of an IC engine is also developed by an electric vehicle. Same characteristics are exhibited. That's how this maximum cruising speed, which is nothing but maximum cruising speed, is going to be decide the performance indices of an vehicle. So if you feel the video is useful, the next part will continue next session. So if you feel the video is useful, please like and share with your friends and give your valuable comments and support your channel. Thank you for watching. Yours Ram.